This is physics, and because this is physics, of course, when we talk about a physical phenomenon, we need to be able to describe it mathematically. We need to create a model of it so we can actually make some predictions about, for example, in this instance, how the motion of the object is related to different variables such as the speed of the object, the radius of the motion, the mass of the object. So just to kind of summarise the motion, I've written some of the variables that are relevant to circular motion down the side here. Of course, we've got mass measured in kilograms. We have radius, which is measured in metres. We have velocity, which is in metres per second. We have force, or in this case we'll call it the centripetal force, and that's measured in newtons. We have the acceleration of the motion, also known as centripetal acceleration, and that's measured in metres per second squared. And when we have a periodic motion that repeats itself over and over, we can describe the period of that motion, which is the time taken for one cycle and measured in seconds. We also have the frequency of the motion, which is the number of cycles that happen per second, and that is the inverse of the period. And we also may use in our calculations angular frequency, which is the number of radians passed, or the number of radians swept out by a particle as it's moving in its circular motion. Of course, we can look at the velocity, and we can say that velocity equals the distance travelled in one cycle, which is 2 pi r, divided by the time taken for that cycle, which is the period. And we can also relate centripetal force to centripetal acceleration, because the force simply equals the mass times the acceleration, which is produced by that force. And the remaining relationship that we haven't yet come up with is what actually describes this motion. For a given circular motion that you observe, what is it that the acceleration actually depends on? And we're going to use as an example something you're pretty familiar with, a car going round in a circle. So this is kind of a warped perspective here, but it's just a car moving in a circle on the horizontal flat ground. Now, you know when you turn in a car and you feel like you're kind of being pushed to the outside. Well, actually what that is the car turning in front of you, and so if you didn't have your seatbelt on, you'd be pushed from the side by the door of the car. So it's actually the centripetal force that's keeping you in circular motion is the car applying a force on you, and that force is directed towards the centre of the circle. So let's have a think just for a moment about what would produce a big force of that car door on you. Well, you know, if you're travelling along and you have to make a very tight turn, so your radius is very small, then that actually produces a really big force on you. So as your radius of motion goes down, the centripetal force required to keep you in that small circle will go up. Also, if you're travelling really fast, and you turn a corner, you're going to feel a much bigger force than if you were travelling at a very slow speed. So a large velocity or a large speed will produce a large centripetal, will be caused by a large centripetal force. Let me just clarify. For a given radius of motion, if you're travelling fast, you'll need a larger centripetal force. We know that force is directly proportional to acceleration, so all those things will also, a small radius and a large velocity will also be associated with a large centripetal acceleration. And we can write an equation, of course, to summarise that, and it turns out that centripetal acceleration is proportional to v squared and proportional to 1 on r. And centripetal acceleration equals v squared on r. Because force equals mass times acceleration, centripetal force depends on the mass, the velocity squared, and r in that way. And that, even though it doesn't look like it because it's tucked right at the bottom of the page there, is the key equation, or they're both the key equations which describe circular motion.